that to talk about angles, the very first thing we're going to talk about is array. Okay, a array is a part of a line that has a beginning but has no end. So it does have a beginning point. Okay, starts at an end point and extends infinitely in one direction. Okay. Okay, a ray is named by its endpoints and any other point on the ray. Okay, because obviously it doesn't have two endpoints. So you have one endpoint and another point that's on the ray. So we would call this ray AB, and we're going to label it with an arrow over the top of it. So anytime I see something like that, I know it's a ray. Has a beginning, has no end. Give you just like a real general idea of this, like solar rays, right? Like light rays have a beginning, but unless they run into something, they have no end point. So you think about light that leaves the sun as a ray, it's a beam of light. It's going to go straight on forever if it doesn't run into anything. Okay. All right. Hopefully we understand that. Two rays. Now this may look like a line. They look like a line, but effectively what it is, it's two rays that have the same endpoint but go in opposite directions. So they're called opposite rays. So ray YX, okay, going from here this way, and then you have ray YZ going from here that way. Okay, those are opposite rays. Okay, they're going to look like a line. So we have 3 points there. An angle. Say this is where we see why we're talking about rays to begin with. Because an angle is a figure formed by two rays that have a common endpoint. So instead of it being opposite rays, where we have a straight line, now we're changing the inflection point. Okay? They have a common point, and that common endpoint is the angle's vertex. In this case, B is the vertex. It's the elbow. Okay? Think about the vertex as an elbow. If from your elbow to your shoulder is a ray, and from your elbow to your hand is a ray, that means that your elbow is the vertex. Okay? And I can extend that thing, okay, until I have a straight line. Okay, I can have opposite rays. The rays, let's see, common endpoint is called the vertex. The rays are the sides of the angle. The sides of the angle here are BA. Okay, I've got that ray, BA, and BC, ray BC. Okay, the vertex is B. An angle can be named by several different ways. You can name that by its vertex. You could name it by a point on each ray and the vertex, or by number. For example, the angle in the diagram could be called angle B. Okay, just because that's where the vertex is, we could say angle B. We could say angle ABC. Now, if I'm going to use 3 letters to name an angle, what letter always has to be in the middle? Does anybody know? If I'm going to name an angle using 3 letters, one letter always has to be in the middle. Does anybody know what it is? Chandler? Well, I mean, okay, let me change this up here a little bit. What if I've got an angle here, and I'm using X, Y, Z. Am I going to label that XBZ? Your vertex always has to be in the middle. So I can call this angle CBA or ABC, but my vertex has to be in the middle. Okay? I'm starting from someplace, going to the vertex, and going someplace else. Okay? Or if they label it on the interior of the angle with a number, we can label it by the number and call this angle 1. So there's in this picture, there's 4 ways to name this. Angle ABC, angle CBA, angle B, or angle 1. Okay? Then we have what is referred to as the exterior of the angle. That's everything outside the angle. This is all outside. And we have the interior of the angle. Okay, the exterior of an angle is the set of all points outside that angle. The interior of the angle is the set of all points between the sides of the angle. Okay, again, I don't think we're in anything here that you guys would have trouble with. You'll find in your book, it's going to talk about this a little bit. A protractor, we don't work a lot with protractors. We're not going to work. I have a whole bunch of them, but we're not going to really mess with them all that much. Is a tool used to measure angles. Unlike segments, angles are measured in degrees. 1 degree is a unit of angle measure that is equal to 1/360th of a circle. What you'll notice is that with, that's not going to let me do that. Try this. That I can move this around. You'll see inside here it's giving you different measures. That's 90 degrees with this point right here. We can move that around and change. But if this is down here, that's 90 degrees. Okay, let's see. It's not giving me anything. Oh, anyway. You need to be careful with what you're measuring because this is 70 degrees, not 110 degrees. So if I measure from this side, then I look at the inside degrees. Or I'm sorry, if I measure from this side, I look at the outside degrees. So this is 100, 110, 120, 130, so far until I get to 180. But if I measure from over here, okay, I'm looking at the interior degree. So as I get closer, those degree measures get smaller. 60, 50, 40, 30, 20, 10, that type of thing. Okay, so we understand, it'll make sense because we'll look at what are acute, obtuse, and right angles. Okay, angles are classified according to their angle measure. Hopefully these are things that you guys have learned about up to this point. Acute angles measure greater than 0 but less than 90 degrees. Has to be less than. It cannot be equal to. It must be less than 90 degrees. Okay? So if it's 90 degrees, it's not acute. Okay? But if it's 89.99999, is it acute?
Yes.
Yes. Yes, it is. Okay? Obtuse angle has to be greater than 90 degrees but also less than 180. Okay, it can be 90.00001 and still be obtuse. Okay, any degree measure between 90 and 180 degrees is obtuse. A right angle will measure exactly 90 degrees. Exactly 90.000 infinite 0. A right angle measures 90 degrees. If I look at it visually, if I see it and I want to know, this is the only way I know visually that this is 90 degrees, is that if I put a box there. Okay? Or if they actually state this is 90 degrees. But if I just see that, do I know that those two lines are perpendicular? No. Because like I said, it could be 89.99999 or 90.00001. In either of those cases, it's either acute or obtuse. A straight angle measures exactly 180 degrees. Exactly. Okay? So a straight line is called a straight angle, or 180 degrees. So let's look at some examples here. Let's see. What is this guy right here? This one. Obtuse. Okay. What's this one over here? Acute. Okay. What's this one up here? Straight. And right. Very good. Okay. We get postulate 4. This is where math actually starts to come into play. At this point, up to this point, we've only talked about definitions. All right. Let's see. Yesterday we talked about the segment addition postulate, right? We could add segments together to find missing links, that type of thing. Today we're going to add angles together to find larger angles. Okay? If point D is in the interior of, let me fix that, angle ABC, then the measure of angle ABD plus DBC is equal to the measure of angle ABC. You add red plus blue and you're going to end up with green. I know that that doesn't work in an artistic sense, but two angles add up to be a greater angle. Do we get the concept behind that? Good. Because just like how we did segment addition the other day, for instance, let's say I know that, let's say this is 107 degrees here, but I don't know what this is, but I do know that the whole thing measures 170 degrees. Can I find out what x is? How? Go ahead, Jordan. Okay. We know what the whole is and we know what a piece is. What do I do? Michael? Right. Subtract 170. Subtract what from it? Okay, and I should wind up with what? 63. Yeah, 63 degrees. Okay, so I know x is 63 degrees. If I knew that this was 63 degrees and I didn't know what this was, what would I do? What would you do, Jordan? What would you do to find ABD if you knew, or ABC if you knew ABD was 107 and you knew DBC was 63? You want to know the whole thing. You add them. Okay? All right, then we're going to talk about, I think this is maybe our last slide, and that is to bisect. Anybody know what it means to bisect something?
Cut it apart.
Okay, cut it apart. But bisect means something very, very specific, like bicycle. What do we know about? How is a bicycle different than a unicycle? It's got two wheels, right? All right, so sect means to cut, right? So bisect must mean to cut into two equal parts, okay? Cutting it into two equal parts. So if I bisected something, I've cut it into two equal halves. I can take a banana over here, cut it, and if I know I've bisected it, I know that both parts are the same, right? I've created two congruent angles. So to bisect a figure is to divide it into two congruent parts. An angle bisector is a ray that divides an angle into two congruent angles. Okay? Congruent angles have the same measure, the same degree measure. They are marked with arc marks, as shown in this diagram. Let's look at something here. X, Y, W. So that's X, Y, W is congruent to W, Y, Z. Okay, so they use a tick mark, okay, through there. Okay, and ZYS is congruent to SYT. So we would use tick mark, okay, through there to show that they are the same. Okay, so that's what arc marks look like. We learned yesterday about tick marks. Now we have arc marks. Okay. So from here, let's try to work out at least a couple of questions. We'll do about 10 minutes, and then I'll leave you guys alone to kind of work on some stuff. Okay? Okay, let's pull up lesson 3 here. I can find it. Okay. All right, so we got ray LH. Ray LH bisects. So this is a question that has showed up on test. So it looks hard. Okay, so this might be a question I'd want to pay attention to. LH. Okay, LH is this ray right here, and it says that it bisects GLI, bisects it. So it's cut it into two equal angles, right? Okay, so I know that this is equal to that, correct? Okay, we want to know what the measure of KLH is. We want to know what this is. Okay, we know that this is 38 degrees here. What do we know about ILJ? What is that? What is ILJ? Can we tell me what the measure angle of ILJ is? 90 degrees. Okay, so we know 90 and 38. So we know at least from ILK, correct? But we're asking for KLH or HLK. So we need to know this little measure right here, correct? Oh, is it 28? I'm sorry, I'd written over it so I didn't see it. Okay, 28. We got 28 degrees. So we need to find this little missing piece here. How do I find that? Huh? Add what? Okay, so Marco says add 90 and 28. Okay, so I'm going to get 118 degrees. Okay, now what? Add it one more time. Add what one more time? Between the I and the H. So right here, you want to add this. What are you? But we don't know what it is. We got to find out what that angle is, right? I can't add nothing. So how do I find out what it is? Here's a question for you. Okay, subtract 180. Okay, so he says 180 minus 118, right? Okay. Why 180?
360 all the way around.
Okay, so because all of this is on a straight line, correct? So everything added up together is going to be 118 degrees. Or sorry, 180 degrees. So what's 180 minus 118? This would be 7, 10, there's 2. Is it 62 degrees? Okay, what are you doing with that 62? What is 62 degrees?
The GLI.
GLI is 62 degrees. So this right here is 62 degrees. Now what? Because all I want is HLI divided by 2. How do you know to divide it by 2? Because it's bisected. So what's 62 divided by 2? What's 60 divided by 2? What's 2 divided by 2? 31 degrees. Okay? So what he's saying is that this is 31 degrees. What am I going to do with 31 degrees now? Add it to what? All right, 118 plus 31, 149. All right, and if you're wanting to be an engineer, this is stuff that you'll need to know. Okay? All right, any questions on that? Because if you see this question on a test, you can't just say, well, I know it's 149. If it's on a test, it's not going to be multiple choice. Okay, you're going to have to know how to get 149 degrees. Even if you've memorized 149 degrees, you cannot pull that thing out of thin air. Okay? All right. Let's see, we got about 4 minutes here. Notice on number 2, do you see a picture? No picture. Can I draw that? I know that I've got a ray, and I know it's bisecting an angle. What angle is it bisecting? QRS. Okay, so at this point, I'm just going to draw an angle. It doesn't, at this point, doesn't matter. Okay, what should I put here up top with this first dot? Okay, what needs to go at my vertex? R, and then, sorry, S. Okay, now what? Now what do I draw? A ray. Where does it need to start from? Is it interior or exterior to our angle? Interior. And what is this ray going to be doing to QRS? Bisect. So it needs to come out probably approximately through the middle, right? Okay. So we know that this and this are the same. All right. This tells me that QRT is 36 degrees. Do I put that as the lower half or the upper half? Where do I put 36 at? Where? Upper half, 36 degrees. Okay. It says what is QRS? How do I find QRS, Marcos? Add what? Add 36. What does an angle bisector do? This is just day 3, guys. What does it mean to bisect something? Divide it into 2, what? Equal parts. So if QRT is 36 degrees, then what is TRS? 36 degrees, right? All right, if this, all right, and this is what I'm looking for, what am I adding to 36? 36. So what should I get? 72 degrees. Okay? Have I lost you guys, or are we still okay? I can't tell if we were lost or lazy. Hold on. Okay. You guys, I'm going to stop there. I know we didn't cover very many questions, but I'm going to let you guys work. I'm going to let you ask questions from the work, okay? So you get stuck, ask questions, let me know. I'll help you out.